Okay, so today what we're going to work on is the review for your next test, which is test number 2. All right, so the first one says to determine if the following are even, odd, or neither. So remember, when you have x, y, if you plug in the opposite x and you get the same y, it's even. Even is equal. Equal evens. If you have x, y, and you plug in the opposite x and you get opposite y, that means it's odd. Opposite's odd. And if you don't get either one of them, it's neither. All right, so let's take a look at the first one. Oh, and also remember that this is, the first one is a reflection over the x-axis. It's actually written like this, reflection over the x-axis. And the other one is a rotation of 180 degrees. Okay, so let's take a look at number 1. So I have f of x is equal to x to the third minus 2x. All right, so I'm going to do f of, let's pick 2. So I have 2 to the third minus 2 times 2. So 2 to the third is 8. 8 minus 4 is 4. And now I'm going to do 2 f of negative 2. So it's negative 2 to the third minus 2 times negative 2. So negative 2 to the third power is negative 8. Negative 8 plus 4, because you have negative 2 times negative 2 is positive 4. So it's negative 8 plus 4 is negative 4. So these are opposites, so that means it's odd. So opposite is odd. All right, let's take a look at B. All right, so we have g of x is equal to 4x squared plus 2x. So let's do g of, 2 again. So it's 4 times 2 squared plus 2 times 2. All right, so 2 squared is 4, times 4 is 16. 16 plus 4 is 20. All right, now we're going to do g of negative 2. So it's 4 times negative 2 squared plus 2 times negative 2. All right, so negative 2 squared is 4, times 4 is 16, minus 4. 16 minus 4 is 12. They're not the same and they're not opposites, so that means this is neither. Okay, and C. All right, we have h of x is equal to 3x squared plus 4. So we'll do h of 2. So it's 3 times 2 squared plus 4. So 2 squared is 4, times 3 is 12. 12 plus 4 is 16. And now we're going to do h of negative 2. So I have negative 2 squared is 4. 4 times 3 is 12. 12 plus 4 is 16. These are equal, so that means it's even. Okay, so let's take a look at number 2. Okay, so number 2, it says find the inverse. Remember, inverse is a reflection over the line y equals x. It means to switch x and y. Okay, so for letter A, we have function d, and I have it as points. So the inverse of d would be 8, negative 1. So we're switching x and y. 3, 0. 2, 5. And 1, 6. All right, B. So we have f of x is equal to 2x minus 9. So let's change that to y equals 2x minus 9. So we're going to change x and y, switch it. So we get x equals 2y minus 9. Now we're going to solve for y. So I add 9. X plus 9 equals 2y. And then divide both sides by 2. So I get y is equal to x plus 9 all over 2. And since it's given as function notation, we write it in function notation. So that's the inverse of f of x. That's how you write the inverse in function notation. Equals x plus 9 all over 2. Okay, next one, letter C. All right, this is already in y equals form, so I'm just going to switch x and y. So I get x equals the square root of 3y over 4. I'm going to put x over 1 and cross multiply. So I get 4x is equal to the square root of 3y. To get rid of the square root, we square both sides. So 4x squared is actually 16x squared, right? Because 4x times 4x is 16x squared equals 3y. Divide both sides by 3. We get y is equal to 16x to the second over 3. Okay, so let's take a look at number 3. All right, so number 3 says, evaluate the inverses of the functions at the given number. All right, so I have m of x is equal to 10x minus 2, and I'm looking for the inverse of m of 4. So I have to find the inverse, and then I'm going to plug in 4. So I'm just going to move this down so I have more room here. So we have m of x. M of x is equal to 10x minus 2. So remember, now I need to find the inverse because I want to do the inverse of m of 4. All right, so I change to y equals 10x minus 2. Switch x and y. X is equal to 10y minus 2. You can put in y equals form. You don't have to, but I'm going to. So I have x plus 2 equals 10y. Divide by 10. X plus 2 over 10. So there's my inverse of m of x is equal to x plus 2 over 10. Now I want the inverse of m of 4. So we have 4 plus 2 over 10, which is 6 over 10, and you reduce that, you get 3/5. Okay, so let's take a look at the next one, so that we're on 3b right now. So it's the same thing. We have here p of x is equal to the square root of 2x plus 3. We're looking for the inverse of p of 5. All right, so let's write this down. We have p of x is equal to the square root of 2x plus 3. And I'm looking for the inverse of p of 5. So that means I have to find the inverse. So y is equal to the square root of 2x plus 3. Switch x and y. We get x equals the square root of 2y plus 3. Now I'm going to solve for y, so I'm going to square both sides. X squared is equal to 2y plus 3 minus 3. X squared minus 3 equals 2y. Divide by 2, I get y is equal to x squared minus 3 all over 2. And that is the inverse of p. So the inverse of p of x is equal to x squared minus 3 all over 2. And now I want the inverse of p of 5. So the inverse of p of 5. So that's 5 squared minus 3 over 2. So 5 squared is 25. 25 minus 3 is 22 over 2 is equal to 11. Okay, let's take a look at 4. Okay, so number 4, we have r of x is x squared plus 1. U of x is the square root of x plus 4 plus x. And then I want to do the compositions one way, the other way, and then do the composition of 5. All right, so let me write them down. Okay, so we have r of x is equal to x squared plus 1. And u of x let me redo that. All right, so we have r of x is equal to x squared plus 1, and u of x is equal to the square root of 4 plus x. All right, so now I want to start with the composition of r of u of x. So I'm just going to rewrite that. So remember, this is equivalent to r of u of x. So now I'm going to replace u of x with what it's equal to. So that's r, and u of x is the square root of 4 plus x. So that means I'm going to go to my r function. Wherever I see an x, I'm going to plug in the square root of 4 plus x. So I have the square root of 4 plus x, and then it says to square your x, I have to square it, plus 1. So when you square a square root, they cancel. So I have 4 plus x plus 1, which is 5 plus x. Okay, so the next one, it's going the other way. So that's u of r of x, which is u of r of x written like this. So remember, it's u of, what's r of x? X squared plus 1, which means I'm going to go to my u function. Wherever I see an x, I'm going to plug in x squared plus 1. So it's going to be the square root of 4 plus my x, which is x squared plus 1, which is the square root of x squared plus 5. And in this case, you cannot this does not cancel each other out because of the plus sign. All right, so that's it for that one. Now I want to do the next part of it, which is R of U of 5. So I'm going to do R of U of 5. So I'm going to do U of 5 first. So it's the square root of 4 plus 5, which is the square root of 9, which is 3. Now I want to do R of 3. So it's 3 squared plus 1, which is 9 plus 1, and that's equal to 10. So R of U of 5 is equal to 10. Okay, so let's take a look at number 5. Okay, so it says find the difference quotient in simplest form. So we have f of x plus h minus f of x over h. Remember, h cannot be equal to 0 because then it's undefined. Okay, so we're starting off with f of x is equal to 6x minus 5. Okay, so let me write down the difference quotient. So the difference quotient is f of x plus h minus f of x over h. All right, and now I'm going to do f of x is equal to 6 minus 5x. Okay, so I'm going to do f of x plus h. So wherever I see an x, I'm going to plug in x plus h. So it's going to be 6 minus 5 times x plus h minus f of x, which is 6 minus 5x, all over h. All right, so I have 6, I'm distributing. I'm going to distribute here. Minus 5x minus 5h minus 6 plus 5x all over h. All right, so we have positive 6, negative 6 cancel. Negative 5x, positive 5x cancel out. So I'm left with negative 5 over h, negative 5h over h. The h is reduced, so I'm left with negative 5. All right, so let's take a look at the next one. Okay, so I rewrote the difference quotient. Now I'm going to do f of x is equal to x squared plus 4. So wherever I see an x, now I'm going to plug in x plus h. So it's x plus h, and I have to square that, plus 4 minus f of x, which is x squared plus 4, all over h. Okay, so now we're going to do, we have to do x plus h squared here. All right, so I'm going to do right here, x plus h times x plus h. All right, so that's x squared plus xh plus h squared. Just going to move everything up. All right, so we have x squared plus 2xh plus h squared. And then remember, we have the plus 4. Distribute the negative, minus x squared minus 4 all over h. Okay, so let's see what we have. We have an x squared and a minus x squared, 0. We have positive 4, negative 4, that cancels. So I'm left with 2xh plus h squared over h. So in the numerator, or I could reduce this, I could make the heart here, right? Everything reduces by h. So I'm left with 2x plus h, and that's my final answer. All right, so let's take a look at 6. Okay, so 6 says to solve each by completing the square. All right, so let me write down the first one. Letter 6a is x squared plus 2x minus 6 is equal to 0. All right, so remember, you always have to make sure you have a 1 in front, and I do. Now I'm going to add 6 to both sides. So I get x squared plus 2x is equal to 6. And then I'm going to do half of 2, half of b, which is positive 1. Square it, which is 1. Add it to both sides. So I get x squared plus 2x plus 1 is equal to 6 plus 1, and 6 plus 1 is 7. I factor this side. I get x, and remember what goes inside is your half of b, which is plus 1. So it's x plus 1 squared is equal to 7. Square root both sides. So I get x plus 1 equals, don't forget the plus minus, the square root of 7. Minus 1. Make sure that goes in front of the plus minus. X is equal to negative 1 plus minus the square root of 7. Okay, so let's take a look at 6b. All right, so 6b is x squared minus 6x plus 3 is equal to 0. All right, again, I have a 1 in front of the x squared, so that's good. So I'm going to minus 3. X squared minus 6x is equal to negative 3. Half of negative 6 is negative 3. Squared is 9, added to both sides. I get x squared minus 6x plus 9 is equal to negative 3 plus 9, which is 6. And then I factor this. I get x and x. And remember, it's my half of b, which is negative 3. So that's x minus 3 squared is equal to 6. Square root both sides. X minus 3 equals, don't forget the plus minus, the square root of 6. Add 3. X is equal to 3 plus minus the square root of 6. All right, let's take a look at 7. Oh. So the next thing we're going to do is number 7, which is find the largest possible domain for each function. So take a look at the function. Remember I always said sometimes it's easier to determine what you can't have, thus leading to what you can't have. So you have a square root here. And what you can't have with the square root is a negative under the radical, because then it's imaginary. So therefore, 5 minus 3x must be greater than or equal to 0. It can be 0, because you can have the square root of 0. It's 0. So I'm going to minus 5. Negative 3x is greater than or equal to negative 5. Divide by negative 3. X is less than, because when you divide by a negative, you flip the sign, less than or equal to positive 5/3. So using interval notations, it's less than negative 5/3, so it's from negative infinity to 5/3, including 5/3, because of the equal sign. All right, next one. So I have a fraction. So think about what you can have. You can't have a 0 in the denominator. So 3x minus 12 cannot equal 0. So add 12, I get 3x cannot equal 12. Divide by 3, x cannot equal 4. So that means it's all real numbers except 4. So using interval notation, so it's from negative infinity to 4, but not including 4, union, that's a union, 4 to positive infinity. Okay, and the last one. So we have a fraction with a radical. So we know that in a radical it has to be positive. We said before over at a, it can be 0, but since it's a fraction, it can't be equal to 0. So x minus 7 has to be greater than 0, because it can't be equal to 0, because then it's undefined. So x is greater than 7. So it would be 7, not including 7, to infinity. All right, let's take a look at number 8. Okay, so number 8, you have to find the relative mins and max, and the intervals where it's increasing and decreasing. So you're going to draw a picture. So I'm going to start with the first one. So we have y equals negative x squared minus 5x plus 3. And we're going to plug it into the calculator, and we're going to get ourselves a picture. And you're going to draw a sketch. Okay, so my graph looks like this. Okay, so I need to find my max here. All right, so that's when you do second calc. You go to number 4 for max. Do left bound, so go to the left of the point. Hit enter. Right bound, go to the right of the point. Enter, and you get negative 2.5. Negative 2.5, comma, 9.25. Okay, so that's my max. Is negative 2.5, comma, 9.25. Okay, so we're going to label this on the x-axis negative 2.5. And then you're going to draw a number line underneath. And you're going to label negative 2.5. Okay, so remember when you read a graph, you read from left to right. So I'm coming from here from negative infinity. So it's from negative infinity, and it'll go to positive infinity. So from negative infinity to my max, it's increasing. So all pluses in here. And then from your max to infinity, it's decreasing. Okay, so it's increasing. So let's write that down. It's increasing from negative infinity to 2.5, negative 2.5. And it's decreasing from negative 2.5 to positive infinity. Okay, so let's take a look at the next one. Same thing, you're going to draw. Okay, so this graph looks something like this. Okay, so we need to find the max and the min. So I'm going to start with the max. And let's see. So my max is at negative 2.67. So I'm just going to write negative 2.7. So that's negative 2.7, comma, 9.5. Okay, so we're going to put that on here, negative 2.7. And now I need my min. It looks like it's at 0, but I'm not 100% sure. I want to make sure. So let's see here. Oh, no, so it's not. Oh, yes, it is. It's at 0, 0, because I got that E. So that's at 0, 0 here. Okay, so on the number line, so you're going to graph negative 2.7, and you're going to put 0 down. All right, and we're going from negative infinity to infinity. Okay, so coming from negative infinity to my max, I'm increasing. And then from my max to my min, I'm decreasing. And then from my min to infinity, I am going back to increasing. Okay, so let's just write down our information. So I have a max at negative 2.7, comma 9.5, and a min at 0, 0. It's increasing from negative infinity to 2.7, negative 2.7, and it's also increasing from 0 to infinity, and it's decreasing from negative 2.7 to 0. Okay, so we have one more to do. Okay, so let's take a look at the transformations. So it says write the equations to depict the transformations. So we're starting off with the parent function f of x is equal to x to the third power. And then I want to write g of x after this transformation here. So I just had to color that out because mine was a little different than yours. I changed it. Okay, so I need a shrink of a third. I need a reflection over the x-axis. And I need a left of 3 units. All right, so since I'm moving left 3 units, okay, left of 3 units, I know that is changing my x value. So when I change my x value, okay, it has to go inside parentheses, so it only goes to the x. That means my cube is going to be on the outside. So remember, when you move left, it's not a minus, it goes opposite. It's opposite the way you think. So to the left is actually plus, so it's going to be x plus 7. All right, a shrink of a third means to multiply by a third. It's a dilation, right, because it's making it smaller. And a reflection over the x-axis means y changes. Okay, remember, this is my y value, the whole thing, so it goes on the outside. If it was a reflection over the y-axis, then it would go on the inside and be with just my x. Okay, so let's do B. So I have here a stretch, so my parent function is the absolute value of x. So I need a stretch of 4. So that's a dilation of 4. So that's a multiply of 4. To the right 6 units. So remember, that's changing the x value. So it's going to go inside the absolute value. And down to, that's changing the whole y value. So let's put down our absolute value. That's absolute value. Right? So I have an x. So I'm changing my x. Let's start with that. So change the x means to the right 6 means to minus 6. I need down 2 units, that means change the y value, so I need on the outside, and a stretch of 4 would be on the outside like that. So be for the absolute value of x minus 6 minus 2. Okay, now we're going to do this from the graph. Okay, so I'm just going to move everything up. Okay, so let's take a look at this. I'm starting off with my parabola, my parent function here. Right, so that's my f of x is equal to x squared. And then I want g of x, my transformation. So I notice that it is a reflection, or since it's flipped down, it's a reflection over the x-axis. It is shifted to the left, so I'm going to count the vertex. 1, 2, 3, 4. So to the left, 4. And then it's shifted up 2. Okay, so we have in parentheses, right, square, because I'm going to change my x value first, so it's going to be x. That would be this part here to the left 4, so that would be plus 4. Up 2, that's changing the y values, that goes on the outside. And the reflection over the x-axis means you change y, so that goes on the outside, right, like that. So you change the whole y value. Okay, let's take a look at D. So I notice here that I have a reflection because I'm going this way and now I'm going this way. This is the parent function, that's this here. If you're not sure, you should graph it. If you're not sure what those graphs look like. All right, so it is a reflection over the y-axis. That means x changes. And let's see, it's up 1, 2, 3, 4 units. Up 4 units. Okay, so I have the square root. Now, I'm changing my x to its opposite. So it's going to be on the inside like that. If I put it on the outside out here, that means it's a reflection over the x-axis. That means my y value changes. So I don't want it there. I want to make sure it's on the inside just to my x. And then I'm up 4, which is to my y value. So it has to be outside of the radical. And be up 4 would be plus 4. Okay, so that's it. And happy studying. Have a good night.